Hi everyone, a little different format today. No script, just gonna walk you through some experiences I had where project managers can get themselves in trouble. One thing I'll just make note of up front, because I've had a few questions. One, for the younger crowd, why don't I use more recent examples? Well, I could, but the problem is a lot of my later career work involved security clearance stuff that I'm not a public figure, so I can't get away with talking about that stuff. I do only talk about examples from the past that apply, continue to apply, so you'll just have to take me at my word for that. Other piece, the Irish part. So, yeah, I'm a retired U.S. major. I did spend a lot of time in the civilian workforce. I'm also an Irish dual citizen. So, yeah, I like Ireland too. So, all that aside, ditching the script for today, I wanted to go over back when I worked actually for a commercial company. So, there was a period in my career where I had left the military and we were designing terminal servers. This was a high tech company. Think of Cisco. You hear about them. Back when they started, there was this company called Xyplex, and I worked for them. And it was a good company. Loved it. Worked with great people, what have you. Was growing at like 30 or 40% a year, which actually back in the day was maybe even a little slow, but dynamic company. Electronics, and been there for about 2 years. This was after having developed a fair amount of experience from the Air Force and my work on the F-111 and the YA-7F. And as a result of that experience, which had a lot to do with reliability, I've been able to move a lot of that over to what today, in terms of the hardware, was similar to how you might build a PC. In the construction of our next generation of terminal servers, our engineers were changing a particular component and a DC to DC converter. Now, if you've watched my video on transformers for the grid, the analogy might be how going to a new material type, like is currently proposed by the Department of Energy, which is a good idea. And in our case, the engineers were going with this new DC to DC converter because it was going to allow them a little more flexibility in how the board was handling the different signals that came in. There were good reasons, and I'm not an electrical engineer, I'm an aerospace engineer, so I'm going to have to take some of this at face value that they went with this particular piece. And similar to like a transformer for a circuit card. They basically just allow you to change the voltages. It was not something that was new tech. That was kind of frankly old technology. It was something that was a known failure rate item. Okay, the fact that transformers fail, whether they're big ones or little ones, is not new. They generate a lot of heat, but it also was usually a fairly constant failure rate and a relatively small failure rate. So with that background, we came and we're launching our new product line. A couple of pieces to understand is the company had just gone public. So prior to that, we were venture capital. Back in the day when venture capital was kind of a newer thing, right? And venture capitalists, well, they want to get their money out of the company, and we had gone public, and the stock had been listed, and they were making a lot of money. And the company's complexion for a person who worked there, it definitely changed. Whereas you were a little more long run focused when you're the venture capitalist, because you're trying to get to a certain point to launch. And I know this may sound a little strange, but yeah, before we went public, we were able to invest with an idea more a year or two in the future. Once we went public, hey, that monthly, and in particular, the quarterly stock statements, things you had to release, became a really big deal. And we did some pretty crazy stuff at times to make sure the numbers looked as good as possible come the end of a quarter. It was not unusual to be working a very late night the last day of the quarter so that you got as much sales out as possible. So, with that background, our customers, we offered a warranty, which is better than most. We had a 3-year warranty. Our product was known as one of the higher quality parts. And in this new product we were putting out, this new server card, the customer in question that was kind of the launch one was a Wall Street firm, of all things. And we were building the prototypes, and my particular role at the company was I was a quality engineer. I'm going to give you a little preview. Actually, at the end of this story, I become the company's quality manager. Not necessarily the way I wanted to become the company's quality manager, but that's what happened. So the product, we built some prototypes. We used our circuit card place to build these prototypes. I work in. Product looks really good. Good sign. So then we're going to go do what a good project should do. Okay, we've built a couple of prototypes. Now we're going to do, in the military, we call low rate initial production. In our case, it was our first 100 cards. We're going to send them out to a beta site and give it a try. So 100 cards are built. Sorry about that. And those 100 cards, before they go out to the field, part of what our department was responsible for is looking and making sure that, hey, the cards passed all their tests. And part of that was an environmental screening test where they were put in temperature. And you're trying to weed out the initial failures, and you're looking for any more significant problems. And lo and behold, wow, this DC to DC converter failed big time. It was like 20% of the cards failed because of this DC to DC converter. And my particular job at the time is I was responsible for supplier quality. Now, here's where a few of the problems start to come into play. The component in question was a new supplier to us. It was made in China, which was not particularly unusual, but it was not bought through our normal chains. I didn't know the distribution managers from that particular company. So when you saw that big a failure rate, it was a red flag for everyone. No one in the company was going to ship the product with that sort of failure rate. That would be suicide. So got back with the distributor who flowed the information back to the manufacturers. Now, I got an answer to what the problem was. And frankly, the fact that I got back an answer so quickly and explicitly was almost a warning flag in and of itself. The answer was that the converter little boards that are inside had not been washed properly. So you've probably heard of fluorocarbons and ozone holes. Well, going back in the day, they were trying to get rid of fluorocarbons. And that was a substance you used to clean printed circuit boards. A new process had been developed called aqueous cleaning, and it worked fairly well, but different companies, it was still a relatively new process, one that worked really well in theory, but actually implementing it could be a little problematic. Okay, and if you've seen my other videos, this is why I'm a little more cautious when someone says, hey, we'll just roll this out. All right, this DC to DC converter, they said, hey, we had a problem with that batch. We were not cleaning the boards properly, but don't worry, we've got it fixed. Okay. I am still worried, right? I was being paid to be worried at that point in time. What I would have loved to have been able to do at that time is, hey, who's my second source? Who's my alternate supplier I can have available? The problem was there was no alternate supplier. This was a very unique voltage set the engineers had chosen to really maximize performance, and it locked us into this one supplier. So this supplier basically needed to work, or we were going to have to respin the entire circuit board, and that would delay product launch by months. And when you're a company and you're a public company, you promise a product launch, that is not something the company wants to do. So, all right, pressing on with the story. Gonna go run another 100 cards. And these numbers, by the way, are approximate. We're going back quite a ways in my memory. Next 100 cards come in, and we end up with 3 failures. Well, that was kind of tricky because 3 failures, when you're just running them for a couple of days under heat of a DC to DC converter, well, that can go a couple of different ways for you. You could interpret that as, hey, those were the bad components. The screen that's in place has gotten rid of them. The rest of them are good. Okay, that's one interpretation. The other is that this is the front end of the curve, and that it's telling you this part has a reliability issue and that you're going to see more failures down the line. And statistics and what have you, when I was bearing in mind that the reason the original parts failed was because of cleaning, I was very concerned that if this was still the same type of failure, that this was telling me it was the latter problem, that this was a warning that these parts were going to have a problem. And without diving too deep into the technical detail, when you don't properly clean a circuit card, what happens is water, the moisture in the air, will get into the flux, all right, which is used during the soldering process. And over time, the moisture will increase and you'll start to get intermittent connections. This problem was not new, but it was a relatively rare one, and it has a lot to do with how much spacing is left between the different pinholes. Today, it would be surface mount technology, but back then, you were doing through hole. So when push came to shove, and my boss came and said, "Okay, are you ready to sign off and say these are good to go?" My answer was, "No, I don't think they're good to go." Maybe that was my military background, which caused me to be a little cautious. It made me a very unpopular person at the company at that particular point in time. And they really wanted someone to say it was okay. Number of meetings were held. A lot of pressure was applied. This kind of pains me because did I know for sure that my fears were correct? I didn't, right? It could have worked out otherwise. I have to tell you, though, in my experience, every time I ran into these situations and I was trying to rationalize why something was going to work when it didn't, I've never had a case where it's turned out that, hey, I didn't need to worry about it. In fact, when I go back through my own personal history, when I have ignored that is when I wish I had. So I also will say that the company decided to release the product. My boss signed off on it. And I don't know that I was going to be fired, but I was definitely not someone who was well liked in the company at that particular point in time. I was concerned for my job. A couple of kids at home at the time, right? So there was, these are not things you can't always, it's not just technical decision, right? I've got to be earning a paycheck. A couple months roll on. I wasn't wrong. The parts started to fail. They started to fail at one of our customers on Wall Street. And when you're getting this sort of a failure, it starts as an intermittent failure, and that's a bad thing. That is, it causes this intermittent failures. The customer's not quite sure. They want good replacements. All right. If you have to pull a card, you've got to be able to have a replacement card and be confident it's going to work. And the problem was we didn't have known good cards. This failure rate had continued for the next couple of months where we would lose a few. There was no sign that the person who was making these parts had fully cleaned up their act. And bear in mind, when you have a problem with a supplier in China who's making chips and you're still a minuscule part of the problem, there's not a lot you can do. So I will cut to the chase here. My boss got fired, head of purchasing got fired. They replaced it with direct material because people had to pay. Right? And I actually got promoted. All right. It's funny, right? I was thinking I was going to get fired, and then I ended up getting promoted. And I don't blame my boss for his decision. Honestly, if I was in the same situation, I want to say I would have put my foot down, but I'm not sure because it wasn't a firm example, and we had boxed ourselves in with the project to this problem. There was a series of points, especially when the problem first arose, that at least then, and I'll talk about risk mitigation more in the future, that we should have started respinning the board so that when it was 3 months in the future and hey, we found this problem, we at least had a solution that was designed and better yet in work. The problem now was because we chose to ignore the problem. Sound like a lot of problems we're having. Yeah, I talk about climate change, and this definitely applies there. But I could take this example and apply it to a whole slew of topics, and it would all work because we chose to not take action when we first had the warnings of the problem. Now it was a really serious problem because basically we couldn't ship product. When we tried, it still failed. That further soured our image in the marketplace. Was that the reason why you don't find Xyplex as a going concern today? Well, I mean, having worked there, I think there was a number, and part of it just is that's a very cutthroat business. And if you have a small misstep, that's it. I don't blame the engineer. I know the engineer was involved too, who made the design choices. He was making them for the best of intentions. So take this example, and I have some other buttes of examples I'd love to share. And think about, hey, when the Department of Energy is saying, let's go with a amorphous steel, and yes, it's going to reduce our supplier base, but it's going to help our transform performance. I like the concept. I admire what they're wanting to do, but it so reminds me of situations like the one I just described to you, where maybe we ought to stick with what we know because the larger issue is expanding the electrical grid so that it can handle renewables and introducing a relatively minor improvement in the grand scheme of things. And forcing it now, I just don't think that's the best decision to be made. Is it a route to go, right? Is the way, in my example, did we need to make changes to the design for it to be keeping up? Yes. But maybe you don't put all your eggs in that basket today because that isn't the thing that's going to make or break your solution. The grid is. And to go back to the example I was talking about, there was both in the design part and in when we were running into the problem, warnings that we needed to change course or at least develop a backup strategy, like say getting Irish citizenship. So with that, this is my example today about the dangers of sole source, how even relatively mature technologies have issues and you have to work through them. I've got another one I could share about the Global Hawk's successful engine-out landing test due to a small change in turbine blade thickness that was within spec, but no one had ever anticipated, except, of course, it was not a test we meant to run. It plane landed safely, but it was not an intended test. These are all examples of why implementation often runs into problems that have nothing to do with the particular new design you're trying to implement. There's a lot of little pieces that take and build up, and that's why you don't get it right the first time, and you have to plan for follow-on improvement efforts. So with that, let me know what you think in terms of, hey, is it better for me to just talk no script, not as many slides, not as many visuals? Love to hear your feedback. Take care, all.